Right, Rhiannon, is that okay?
We can see your presentation.
Oh, okay. I'll do
Yeah,
that.
so we're good to go.
Hello, sorry for the slight technical delay, and I'd like to thank everyone that's organised today's forum. It's been fantastic so far, so hopefully I'll make it continue on in that vein. We'll give it a go. My talk's on really the culmination of about 6 years of monitoring the outcomes of environmental watering in the Northern Murray-Darling Basin. Got a list of co-authors that I want to acknowledge first up, Darren, Mark, Sarah and Gavin. And if I go to the next slide, which is, here we go, is the logo page where there's a bunch of collaborators and funders and people that work with this project. And that's not all of them, that's just the main groups. I'd also like to acknowledge that I work and happily received on Kamilaroi and Gurnu-Barkindji country for my projects, and I work across many other great Aboriginal nations. So what I'd really like to talk about is kind of the Northern Murray-Darling Basin where I do a lot of my work, and it's been fantastic to have Zach and Fran and Ian talk earlier today about these kind of strange rivers that live in Central Australia and the Northern Murray-Darling Basin included, that are very atypical compared to what we probably think a proper river is, given our kind of European version or UK version of what a river might look like. The rivers I work with aren't like that, and I'd really like to acknowledge the great presentations that really covered that in detail earlier today, because I won't. That's my focus. It's the Northern Murray-Darling Basin. It's really the Darling catchment, which is about 2/3 of the total area of the Murray-Darling Basin, and about 0.1 of the total water contribution in most years. As we've heard earlier today, the rivers in the basin are kind of funny, and it's in a reverse clockwise direction. They go from probably what many people might consider a proper rivers, those things that flow all the time, have water in them, have sinuous bends and trees along them all the way. And as you go around that reverse clockwise direction, you lose stream power and you lose discharge, and you get up into the north, the Warrego River, the Paroo, and the most common flow rate for these rivers is zero. They're mostly dry. They flow intermittently with largish pulses of highly turbid water, and they function very differently to the rivers down south, Victorian rivers that flow into the Murray. I won't talk too much more about that. Lead on to this kind of fairly startling graphic, and I'll explain it in a bit. My talk, I'm going to preempt it by saying I've got a section of some fairly dodgy maths, rampant spreadsheet calculations, and a couple of graphs, but no statistics. But this is a pretty striking graph that my colleague at the Commonwealth Environment and Water Office, Lindsay White, gave me the other day. It shows the Darling River flows at Wilcannia over about a 60-year period. And there's some periods of no data, so you ignore the grey little bits. But the yellow lines are where the river stopped to flow at Wilcannia. And you can see in the first part of this graph, there was definitely periods where it ceased to flow, and for reasonably long times. But as we got into the 2000s, into the Millennium Drought and the recent big strong drought, the biggest drought we've had in the Northern Basin, you can see that the frequency and the length of the duration of this cease to flow has increased dramatically. I don't have any stats for that. I haven't compared it to weather records or seasonal decadal cycles of climate. But to me, it's quite striking that we're really drying that system out and ceasing the water flowing down a lot. That's part of what we'll be talking about today. My two focus areas particularly are the Guida wetlands to the west of Moree, and the Warrego River, the lower Warrego River, where it joins the Darling River a little bit to the west of Bourke. And we also focus a little bit on all these rivers that feed into it. Mostly we do our work in there. Just to emphasise the different nature of these rivers, this is a picture of me in the Guida River. So if you go West of Moree, you follow the Guida River, the blue line, that is the Guida River. That's it. I'm standing in the middle of it with a industrious afternoon with a spade. I could fill that river in and make the flow go substantially in different directions. It's a really small thing. The Warrego River is this one. Both the other two photos of the Warrego in that lower section. Now this is when I walked across the blue line, this bottom photo, and well, I kind of occasionally call myself a fluvial geomorphologist. I couldn't really find a channel that I could call a channel. There were multiple flood runners that would change dramatically with each flow event as the sands and sediments and logs and things move around. So really, they defy our current definitions of what a river might look like. Well, certainly they have a new definition. I just want to quickly cover three events that stand out, so three things that stand out in my study in the recent times and my work in the north. A northern connectivity flow, the interactions with golden perch and the Warrego River flowing, and just trying to quantify the boom. How big is the boom when it gets on to some of our floodplain wetland areas out in the northern Murray-Darling Basin. Now in 2018, lots of the Darling looked like this, and it continued on into 2019 for long periods of time. It was disconnected, there were fish kills, there was poor water quality, communities were running out of water. It was pretty dire and pretty stressful. I was lucky enough to be involved at that time with a group, an interagency working group that was looking to better manage, to come together to better manage environmental watering. And I got to share, even though I was on the edge of this group, got to share in some of the negotiation and cooperation that went forward to bring together what was the northern connectivity flow, where they took water from Copeton Dam and Glen Lyon Dam and were able to deliver it all the way down to Menindee to connect the entire Darling River, or at least for a period, to refresh the floods, or the pools in the lower Darling River, and sustain some of that life in the community for a bit longer. Now, it was reasonably exciting to be involved in that, because it was a great achievement, not just the engineering to get the water out of these dams at the right times to connect up and flow that very long way in very hot, dry conditions, but it was the first time that I can understand that northern basin had been deliberately connected for the environment and for people. And it was the first time that I'd seen all of the water agencies, and I do mean all of them, there's about 10 of them, working together actively to try and deliver the water, understand where it was going to come from, but then also protect it as it went downstream, liaising with irrigators, liaising with landholders to make sure that that water got where it was needed to be in that critical time. It was an outstanding culmination of really some of John Howard's work, bringing together the basin plan, and then continuing on through, I guess, the Four Corners report that highlighted some of the systems in New South Wales a few years ago, right up to now, where we've got a more collaborative and engaged, cooperative way forward with environmental water, which I find quite promising. Being involved in that, at least on the side, was really quite exciting. And that's kind of the outcome. That's young Ewan Walford down on the river, the Darling River near Walgett, enjoying his a nice young yellow belly there that was about to go on that fire, I think, for young Ewan. The next little story that I'd like to share is about some of our science findings about yellow-bellied dargay. This is the print, you can see in the back, just behind me there, if you're looking at the screen, from a local Kamilaroi artist up in Inverell, Brent Emerson. His link is down the bottom if you wish to contact him. He does some wonderful contemporary stuff. And what we found in our study is that the Warrego River, when it has a flow in it, and even a small flow, when it connects from the upper reaches into the lower reaches, which is our study area, the confluence with the Darling, each time we've been out there and measured it, we've found an outstanding, not only spawning response from golden perch, but a recruitment response. The fish, as they spawn upstream and they drift downstream over that maybe 6-week period, and if you look at this graphic, the little rectangles are the areas where the spawning was first detected, and downstream is where that the smaller recruits, 5 centimetre long fish were found in the lower Warrego. Every time we've measured it, we've found an incredible spawning response where we get tens of thousands of golden perch. Now, they don't just breed and lay and have eggs and larvae, they actually get to viable fish size each time. So we're pretty sure, and some of the early genetics are showing us, that the Warrego River just has the right stuff to be an incredible golden perch nursery for the entire Darling River at least, and possibly to the full Murray-Darling Basin connecting along the way. Now, fairly early work, we've only been doing this for a while, and I've got to admit, it's Gavin Butler and his team that are doing it. I'm just watching on the side. But the fact that we can get tens of thousands of fish produced for each pretty small flow is quite incredible. We've got a remarkable nursery that allows us to maybe seed the rest of the basin. Worth protecting. The other thing is trying to quantify the boom that happens when we get a bit of a flow and a bit of an inundation event. And we get those periodically. This year on the Warrego Western floodplain in April, we got the largest flow and inundation event that we'd seen in the 7 years of study. We had over 10,000 hectares of floodplain inundated, and it connected right the way from the main channel, right the way down the western floodplain into the Darling itself down there, and also down the Warrego Channel proper, and connected for a relatively long period of time. Unfortunately, we couldn't get out and measure it. We were in lockdown with everyone else, but we could see it vicariously via satellite, which was pretty good fun. What I'm going to try and do now is present to you some remarkable spreadsheet magic in give you some idea of the production that comes about in a 6-week inundation period. What we know is that when that water goes onto that floodplain, it produces very rapidly a whole bunch of microinvertebrates, little small animals that are really the base of the food chain. Lots of things eat these things. If we take a sample, what we find in a standard litre is anything up to 78,000 of these, but some, let's say, a really conservative estimate of 1,000 per litre. That's, if we scale it up to kind of an average hectare, that's maybe 1 billion animals per hectare, which is about 500 kilograms, half a tonne of mass, which is probably a cow's worth. If we then take that over a 10,000 hectare inundation area over a 6-week period, we can quickly get to 60 trillion of these animals, which is a 6 and then I think 13 zeros afterwards. Forgive me if I'm wrong with that, which is about 30,000 tonnes of production in that period. And if we want to take it into kind of an agricultural production equivalent, maybe 50,000 cows produced in that 6-week period from one flow event. Now, we've got a bit of work to do, and my colleague Darren Ryder will be squirming a little bit at my looseness with numbers, but that's kind of the order of magnitude of production that we get from one inundation event. If we scale that over the whole northern basin, when a large flow goes across the Darling floodplain and some of the other larger floodplain wetlands are connected, we might have 1 million hectares of inundation. And I haven't done the sums, but that's a lot of cattle produced in one flow event and a lot of productivity across the landscape. We're lucky enough to be able to measure not only the small bugs, also the bigger bugs that come out in droves the minute we get them. I haven't done the sums of kilograms of these things. I've set that as a summer holiday challenge for Darren to work that out. We then find a lot of frogs, lots and lots of frogs that breed across that wetland at different times, particularly when there's water there. A lot of fish that come down, tens of thousands of yellow belly that come down that system each time. And this large event that happened in April maybe put hundreds of thousands of yellow belly into the system. And then pretty much the top end predators we have out there are the larger birds, the pelicans, the ducks and the brolga that live and feed on those landscapes. Thank you very much.
Thanks for that, Paul. Just to see, does anyone have any questions?